Hello everyone, my name is Sagarap Krupanandam and welcome to my project demonstration on fake news detection using Ultramodal Pattern Recognition. For this project, I choose not use a complex model. Instead, I chose Ultramodel, which is a system designed specifically for interpretable pattern recognition. The goal of this project is just not to get a real or fake label, but to understand why the models makes a certain decision by looking at the specific word and phrase patterns it identifies in the text. I have implemented this entire project in a Jupyter notebook using Python, and the primary libraries are pandas for data handling and scikit-learn for building our model. Now let's walk through the code cell by cell. Coming to the first step is setting up our environment. This cell uses a pip install to make sure we have all the necessary libraries like pandas, scikit-learn and matplotlib and cbourne. Next, coming to the cell 2, we import all the functions and classes we need. We are bringing in pandas for data frames, TF-ID vectorizers for which we will be used for converting raw text documents into matrices, and logistic regression for our model, and matplotlib and cbourne for creating our plots. And coming to the third cell, here is where the data work begins. I loaded two separate CSV files, one containing fake news and the other one with true news. Then I performed three key processing steps. I added a label column as 1 for fake news, and for true news I added a label column 0. I combined the title and the body of the articles into a single full text form. This gives our model the maximum amount of context. Finally, I combined both the frames and I shuffled them randomly to ensure our training and testing data is unbiased. And here we can see the output. And coming to splitting the data, with our data prepared, I split into a training set and a testing set. I used an 80-20 split, so 80% of our data is used for training the model and the remaining 20 is held back to evaluate its performance on unseen data. I used stratify option to ensure that both the training and test sets have the same proportion of real and fake news. Coming to the cell 5, here creating and defining the Ultramodel pipeline. This cell is the main, in my terms, I'd say it's the this cell is the heart of the project. I defined our Ultramodel using a scikit-learn pipeline. A pipeline chains multiple steps together, which is very efficient. Our pipeline has two stages. The TF-IDF vectorizer. This is our pattern recognition engine. It converts the raw text into a numerical matrix. It defines most important words and phrases by looking at their frequency. And I configured it to look at the both single words and two phrases, and to ignore common English stop words. The logistic regression classifier. When we say TF-ID vectorizer is our heart of the project, I say logistic regression classifier is the brain of our model. It is a simple, fast and highly interpretable algorithm which takes the numerical patterns from the TF-IDF and learns to classify them as whether it is either fake or real. We can see where we can here it is a model training. This model is incredibly fast and simple in my terms, with the pipeline defined. A single call to model fit on our training data is all it takes. The pipeline automatically handles the vectorization here, and classification training is on one step. And coming to the validation and plot training, a key requirement is to show that our model has learned properly. For this, I generated learning curves as we can see here. This plot shows the model performance and it's trained on more and more data. The red line is the accuracy on the training data itself. On the green line is the average accuracy on a separate cross validation set. As we can see here, the green line, and it is a red line. Red line is for training score, and the green line is for cross validation score. The most important thing to see here is that the both lines converge at a very high accuracy level. This is the ideal result. It tells us that our model is generalizing well and is not overfitting to the training data. Coming to the next cell, here we evaluate the model on the unseen test sets. Now we evaluate the model on the completely unseen test data. Here it is a classification report. Here we can see the classification report gives us detailed matrices. As you can see, like we achieved an overall accuracy of 99%. The precision, the recall, the F1 and the support are extremely high for both the real and fake news here. And coming to the confusion matrix, the confusion matrix actually gives us a visual breakdown of the results. The numbers on the main diagonal the numbers on the main diagonal shows the correct predictions. We can see that out of nearly approximately like 9,000 test articles, the model only made a very small number of errors here. As we can see the errors here for both real and fake. This confirms I think it's a excellent performance. And well, it's coming to the predicted now it's coming to the expected learned patterns. This is where our pattern recognition actually approach shines very well, because our model is interpretable and we can look inside it, see exactly what it learns. Here we can see the words and phrases. Mostly the model found to be strongest indicators of fake news. Words like here Trump, Hillary, and by other sources like 21st Century Wire have very high positive scores. As well as coming to the real news here, these are the patterns that strongly indicate real news, like the model learned that official sources like here Reuters and objective phrasings like it's on Tuesday, and political figures in a formal like Donald and something etc. In a formal context, signs of these are all I think formal contexts are signs of legitimate articles. Now let's coming to the correct and incorrect predictions from the data set that we have given. So after running this cell, we got 3 correct predictions and 3 incorrect predictions. While coming to the first correct predictions, actually here the true label labeled as like it's a fake news. Predicted label also shows it's fake news, because as we can see here in the text beginning itself only it's showing it is unreal. That means it detects that this news is completely fake. So that's why the predicted label gave fake news. Now it matches the true label and the predicted label, so that's why the prediction got corrected. Coming to the next example, true label is real and predicted label is real. Just because we see here this kind of text in articles like routers and legislation and seeking, these kind of big words we usually see in articles. So it detects these kind of words as real news, so it matches to the true label as real, so both are correct. Coming to the third one, it's like the same thing related to the example 2. As we come to the incorrect predictions, here we look into the example 1. We saw true label as fake, predicted label as real. Because as we see these kind of text is looking like completely it's like a true news, because the fake article this fake article was cleverly designed to include this real news, some kind of signals etc., which fooled our pattern recognition matching system. It shows that the model can be deceived by fake news. So that is written to sound professionally hard and objective. And coming to the incorrect incorrect prediction, that is example 2. As we can see here, the model predicted fake, but the article was actually real. Why did it fail? Means looking at the text, we can see it uses a word. Actually, the article was real. It contained a pattern that model. The model was trained to associate with fake news, leading to the error. This ability to diagnose failures is a huge advantage. And coming to the third one also, it's a true label. A true label is fake, and the predicted label is real. Because this kind of, as we can say, related to the first example, completely this news is relevant to the true news. Like it's completely showing this entire pattern is like a true news article. So that's why it thought, our system thought it's a real news, but actually it is a fake news. Coming to the conclusion, finally, after being satisfied with the model, I saved the entire trained pipeline using joblib here. This PKL file can now be loaded into another application for real world use without needing to retrain. So to conclude, this project successfully demonstrated that an interpretable pattern recognition model can be extremely powerful for fake news detection, achieving 99% accuracy. The key advantages of this Ultramodel approach is its transparency. We can see exactly which textual patterns are driving its decisions, which allows us to both trust and its predictions and diagnose its failures also. For future work, this model could be easily deployed as a web application or enhanced by adding even more features like analyzing punctuation or sentence structures. And so that's all about my demonstration, and thank you for watching.